OpenShift Data Science. From here on out, you may hear me say Open Data Hub or ODH. And for Red Hat OpenShift Data Science, I will most likely be saying RHODS. Those are just short little acronyms we use for those. So if it gets confusing, feel free to kind of throw up a question and stop me. But from there, we'll just go ahead. So I will give an overview of ODH and RHODS, the community and cloud service for artificial intelligence, machine learning on OpenShift. So the agenda is we're going to cover ODH, Open Data Hub, and then we'll dive into what is RHODS, why did RHODS come about, how RHODS works, and how RHODS is different from other partner products. And then if we have time, which we should, I'll give a quick demo of ODH and then kind of walk you through hands-on how that translates to, or ODH translates into RHODS. So first thing, I am Landon LaSmith, one of the engineers that works initially on Open Data Hub, but one of the many members that contributes to RHODS. So with Open Data Hub, there's multiple people, both internal and external to Red Hat that work on Open Data Hub and all the other downstream components for that. So I'm just one of many that contributes to it and maintains it. So Open Data Hub, this is, sorry, I need to update this slide, but Open Data Hub came about as initiative to build a platform for data science. So we wanted to allow data scientists to kind of go through their workflow as seamlessly and kind of effortlessly as possible to have access to all the tools that they need without worrying about the underlying infrastructure. And there was a need to make sure that they could collaborate with others on their team and make it as scalable as possible. So as a data science, you want access to all the tools and all the resources at a moment's notice. So that begat, what is now the Open Data Hub running on OpenShift. This began probably 4 years ago, I think thereabout, with an internal initiative, which we call the Internal Data Hub. And there was a goal to kind of take those experiences, best practices, and techniques and make them available to the community. So that's what became the Open Data Hub. So as a team of data scientists and developers want to work together, previously it was hard to do that. So there was kind of, everybody had their own little kind of tool set, their own little kingdom, and they didn't play nice together. So part of the initiative, from 3 or 4 years ago is to kind of bring all of those technologies and tool sets out into the open without having to worry about kind of, sharing resources, making sure they work together, and then delivering all of that work into production. So with the Open Data Hub project, it is a project to work in a hybrid cloud environment. So we want to make sure that there's no kind of vendor lock-in, there's no proprietary lock-in, and you can run your tools and kind of processes on any kind of hybrid cloud. So hybrid cloud means on-prem, whether it's OpenStack or, I guess VMware, if you're going to do that. Definitely OpenShift. OpenShift is kind of infrastructure agnostic, whether it works in a Microsoft environment, IBM Cloud, AWS. You can work it wherever your workload lives. And we want it to be open source. So it started off as a meta project, meaning the Open Data Hub deploys additional applications that aren't necessarily under our control, but we contribute to. So this could include things like, definitely Jupyter Hub. We have our own kind of opinionated deployment of that, different tools like Superset, Argo workflows, Tecton pipelines, which is now part of Red Hat OpenShift, and even Kubeflow tools. So we're kind of tool agnostic. We just make sure that it integrates well together and works well on OpenShift. And you can deploy Open Data Hub now as a community operator. And once we get to the demo, I'll kind of show that off. But the main workflow for Open Data Hub is kind of this cycle that you see here. We start with the data ingestion, data storage. This is where the data engineer would typically live. And then once that's kind of curated, that data's curated, you can pass off to the data scientist who will perform their workflow, model training, model building, and then pushing that model out to production. We'll cover what a community operator is. Sorry, I'm kind of jumping off back and forth, but the DevOps. So we want to make sure that once the data scientist has performed their work, they push that model out, that we can serve that model either to kind of a certain application or even push it to the edge, with the edge being kind of, point of sale device or some edge cluster that a user is using in their workflow. So when I say community operator, I'll cover this in the demo, but within OpenShift, and even if you're deploying vanilla Kubernetes, there is operatorhub.io, which is an initiative to kind of provide I'm using the term marketplace, but there's currently, there's no price associated with it. There is on OpenShift, but primarily operatorhub.io. You can go to the Operator Hub marketplace and search for different operators that will provide easy deployment of certain applications, Open Data Hub being one of them. But I'll kind of show that off to explain it a little bit better. So Open Data Hub is, like I said, it's an open source kind of project. So being open source, we have a upstream and a downstream. Now this is an older graphic, but it's still relevant today. So we have Open Data Hub sitting in the middle, and then it's available on Operator Hub. When I cover RHODS, I'll explain how that RHODS links into this flow. But when we say upstream is typically a public project that's worked on by a greater community. So you'll see at the top of that funnel, you'll see things like Selden, Jupyter, Kubeflow, Spark. We have the icon for Argo, Prometheus, all of these popular tools that are used in open source environments work on Open Data Hub. So we don't modify these specifically to work in Open Data. Well, we make changes and contribute them upstream so that they work well on OpenShift, but we're not customizing these applications heavily so that there's that different from what's available upstream. And we take those applications, kind of deploy or configure them within a Kubeflow manifest, well, KFDF manifest format, and allow that to be deployed on OpenShift. So all of these applications can kind of work together with some restrictions based on how they function. Kubeflow and Jupyter won't necessarily work well together as a whole because Kubeflow has its own notebook controller. But we can use, Selden with Kubeflow and certain Kubeflow components, potentially KF serving. I think Katib and I think TF serving, but I forget. We could kind of integrate those with Open Data Hub components and have those work on OpenShift. So you can deploy Kubeflow on OpenShift, not just vanilla Kubernetes, and it does work extremely well. So the Open Data Hub operator, I know many of you, I guess, being interns, you may not be familiar with an operator, but their operators are, they control the life cycle of different Kubernetes objects. So instead of having to deploy kind of, multiple OpenShift objects, deployments, images, controlling the services and the routes. If you just want to work with Jupyter Hub, then with the Open Data Hub operator, you can just tell it to deploy Jupyter Hub without writing any code, and it will automatically deploy all the necessary or required objects for that to function. So with the operator, we are now at phase 4, which means we control everything from basic install to deep insights. So we can handle upgrades from one version to the next and allow you to query metrics for those applications. So our current operator is written in Go. I say current there's not going to be a change to that. So it's written in Golang, and it's open source. So feel free to review that code and submit PRs if you want. But we'll kind of skim over this part unless there are questions. So RHODS, Red Hat OpenShift Data Science. So this is based on upstream Open Data Hub. So if you go back to the diagram where we had the upstream applications, ODH, and then downstream is Operator Hub, RHODS would sit below Open Data Hub in this component. So RHODS is now part of the Red Hat Managed Service Initiative. I think we were announced at Summit along with Managed Kafka and I'm forgetting the other one, which Sherrod's going to yell at me for. But we're a fully managed service, and I'll explain what that means. We're tested and supported AI ML tooling, but we still maintain that initiative of no vendor lock-in. API management, Rome. Thank you, Sophie. So Red Hat OpenShift API management was the third managed service. A choice of technology partners, which means we're not locking you into Open Data Hub components, but we are working with other Red Hat managed services to provide you a kind of fully functional 90x% uptime for that service. So you don't have to worry about deployment of or management of that infrastructure. All you need to worry about is, do I have access to my tools and is it working successfully? So Open Data Hub is based on Open Data Hub and Operate First. So Operate First kind of sits between, Operate First is a long-running deployment of Open Data Hub with a lot of hands-on user experience. So in Open Data Hub, we're doing the work to kind of make sure these components work well in OpenShift. But as we're kind of, saying ahead of the curve to integrate these components, there's a great need for us to have the user experience and a long-running deployment with hands-on users, and that's where Operate First comes in. So I think you just had a talk about that or a class on that, so I won't go deep into that. But Open Data Hub is consumed by Operate First. And then we get a lot of kind of feedback from users that are using Operate First, and that makes it back. Those changes, suggestions, fixes make it back into Open Data Hub. And RHODS is a direct downstream for ODH. So a lot of the components, right now it's just Jupyter Hub, and the dashboard are consumed by RHODS as the managed service, which is running on top of AWS. And with optional ISV offerings, this is kind of the additional managed services that are made available by Red Hat. So that is Kafka and Rome, the API management. So why did this come along? This is designed to be a complete solution for the customer. So they can deploy, sign up for access to RHODS. It's a paid service, and they get a fully supported product that is guaranteed to be working for users. So with Jupyter Hub, we want the user to expect that, no matter when they go to access that managed service, that it's available, working, and it suits their needs, and allows them to work without worrying about the underlying infrastructure. And a simplified approach to AI ML, we want to make it as easy as possible so that the user deploys it. They don't have to worry about anything else other than their workflow. All right, 1 second. Sorry. Okay. So Red Hat Managed Cloud Services. So this is kind of, a heavy marketing slide, but what you can see here is the kind of breakdown, the stack of how a managed service is provided. So at the very bottom, we have different cloud providers. These cloud providers are the underlying infrastructure where a managed service can be deployed. So AWS, Azure, IBM Cloud, Google Cloud, and even a customer data center. So if they're running on-prem, maybe in a disconnected environment, they want to be able to deploy these or have access to these services. So the platform services are AWS, and then we have OpenShift running on Azure, OpenShift running on IBM. So these are all the places where OpenShift can be deployed. So the only restriction on where you can deploy Open Data Hub and by extension Rhodes is that it supports OpenShift. We don't care about whether it's AWS or Azure, IBM Cloud, Google Cloud. It doesn't matter to us. All that matters is OpenShift runs and it's running well. And on top of those OpenShift deployments come the managed services. So Roam, Kafka, and Rhodes are these managed services that were just announced at Summit. These are what the customer is signing up to pay for with the guaranteed a guaranteed uptime. So they don't want to worry about the management of it. And on top of that, we take feedback, we implement new features to kind of streamline the experience of the user. So this could be things as, hey, your default notebook sizes are too small. Can we get a bigger size? We make that available. In some use cases or edge cases, we may allow them to customize that to their needs, but that's available. Other times it could be, hey, this I don't have access to service. This is a bug, and then we'll fix that with the flow of that fix potentially going upstream to ODH and then making it down into Rhodes. So the how. This is kind of how the managed service for Rhodes works. So at the bottom, we have hybrid cloud, OpenShift Dedicated. And if you're not familiar with OpenShift Dedicated, just know that OpenShift Dedicated is a managed, I don't want to overuse the term managed service, but it is OpenShift that is maintained by Red Hat. So we've been talking about managed services with respect to Rhodes, which is just an application that runs on OpenShift. OpenShift Dedicated is the kind of the underlying infrastructure, that Rhodes runs on. So with OpenShift Dedicated, this is a highly controlled OpenShift deployment that is managed by Red Hat site reliability engineers. And it's constantly updated. So the user has admin access to the cluster, but they do not have full cluster admin access. That is tightly controlled by the Red Hat SREs, site reliability engineers, to control the full life cycle. So all the user can do is primarily kind of, install applications and configure those applications, things like the underlying nodes and, even kind of custom identity providers and other things like installing actual GPUs and hardware. That's controlled by the engineers that manage OpenShift Dedicated. So on top of that are the managed services. So you'll see Red Hat OpenShift Data Science. Rhodes provides Jupyter notebooks with support for TensorFlow and PyTorch CPU and GPU notebooks. And then you have the freedom to kind of work with any environment that you want to, whether you're storing your data on-prem with OpenShift Container Storage or in the public cloud, AWS, you have full access with some freedom to kind of install the packages that you want. And we use source to image to kind of customize these images so that we can build them on the fly. We update a repo, point the source to image config at that repo, and we can build it in cluster on demand as necessary. And then some of the managed service, Starburst, Anaconda, IBM Watson, Seldon Deploy. These are all partners or ISVs that Red Hat has a relationship with, and we partner with them to make their applications available in this managed environment with, benefit to them, allowing kind of a revenue stream back to their application. Okay. So I won't get into this part. This is more kind of Sophie's wheelhouse, so she can explain it much better than I can. So just know that we have a focus on kind of making the life cycle of a model as seamless as possible. Um, so from data ingestion all the way to building, training, and serving, we want to streamline that process with Rhodes. And these are some of the partners that we uh, teamed up with to make that happen. So how is Rhodes different from the alternatives? So again, Red Hat is big on hybrid cloud. We want to make sure that our applications and services run where your workflow data lives. So if that's AWS, Azure, IBM Cloud, or Google Cloud, we make sure that OpenShift works there. And if OpenShift works there, then Open Data Hub works there. And we're a fully managed cloud service. So other places will just kind of deploy it and then hand it off to you, and you're on the hook. So with Red Hat managed services, you get that support, underlying kind of DevOps admin support to make sure that everything you rely on for your workflow is running. And open source innovation. This one is key because a lot of vendor lock-in proprietary technologies land with this huge fanfare, and then 1 or 2 years later they're stagnant. So with open source innovation, we're constantly getting updates, requests, PRs to improve the product from a wide range of user experiences and knowledge. So we're constantly updating and staying at the edge, the bleeding edge of technology within reason with what we can support. And then partner ecosystem. So we don't lock you into just Red Hat products. We work with other vendors outside of Red Hat to make sure that whatever the best application or service is to provide you that feature, we can work with. So that's part of the Red Hat initiative that predates OpenShift, and that'll be around a long time after. So open hybrid cloud, this is kind of a breakdown of what open hybrid cloud means. Again, keep stressing this. The underlying technology is Linux, and Linux runs everywhere. So that's physical, virtual, private cloud, public, or edge. Edge is huge now. So we want to make sure that Linux, OpenShift, Red Hat, period, has a presence on those edge devices with its point of sale machines, small single cluster machines deployed out in the field. We want to make sure that you can run your AI ML workflows with those machines, whether they're just passing data back to a central server or you're doing kind of a small type of model training at that edge device. We want to make sure that we handle those use cases. And then on top of all of those underlying devices is Kubernetes. When we say Kubernetes, we mean OpenShift. We want your applications and microservices and everything else to run on OpenShift as seamlessly as possible. So this is just a conceptual machine learning architecture. This is kind of gives you an idea of like how the everything I'm talking about, hybrid cloud, and all of the other supporting technologies work in AI ML. We won't cover the infrastructure part since I beat that to death. Compute acceleration. These are different things like, different type of OpenShift nodes, whether it's GPU accelerated, memory optimized, CPU optimized, and you want to make sure that your specific workloads can run on those. We can do that. And hybrid multi-cloud. So you can work with different platforms, whatever fits within your workflow. And on top of that are the applications. So your data lake, data storage. Anytime you're working with AI ML workloads, you've got to have somewhere to store that huge mountain of data. I think in the internal data hub, this is an old stat, but I think they were processing I can't remember if it was 4 terabytes or 14 terabytes of data a day for the internal data hub, but it's definitely, terabytes. And you want to be able to use that data in your workflow. So develop your model, deploy your models using Kafka, streaming it from a data lake from a data lake, and then set up alerts and be notified when you need to kind of retrain that model and monitor your infrastructure. So these are some useful links that you can only get in the slides, but Red Hat OpenShift Data Science, this links to the announcement about RHODS release and what it is. And there are RHODS repos under Red Hat Data Services. I think most of these repos are public, even though they're consumed by our downstream paid product. But the real meat and potatoes, I guess, of what you want to be able to kind of interact with and look at is Open Data Hub. So we do have an org on GitHub. So GitHub /Open Data Hub -IO is where everything lives. And then within that repo, or within that organization, we have ODH manifests. Thank you, Anish. So I think that's the last slide. So I'll see if I can go to the demo. Hopefully you can still see the presentation. So if you want some more information about kind of AI, ML, Open Data Hub, and best practices, we have opendatahub.io, which is our website where we post information about updates to Open Data Hub, links to relevant conference talks or presentations that anybody in AI COE or the AI services team has done. So you can go to news and you'll get a whole list of releases for different versions of Open Data Hub and information on how to join the community. We have a bi-weekly meeting for Open Data Hub to announce new features. And then you have documentation for how to deploy Open Data Hub and different features or within that AI ML workflow. So, if you want to enable a GPU in your cluster, deploy the data catalog, learn how to install Open Data Hub on your OpenShift cluster, you can find those instructions here. And also deploying Kubeflow on OpenShift if you're interested in that. So since we have time, I will kick over to a demo. So we're going to do this live. So I'm going to cross my fingers that everything's working. Sometimes we have cluster issues internal to Red Hat, but we should be fine now. So what I'm going to go through is kind of a quick install, which you can go through the documentation on opendatahub.io to follow along. But this is just going to be a quick demo of how you can deploy Open Data Hub in your OpenShift cluster. So I've been saying, you can deploy on OpenShift, you can deploy OpenShift anywhere, but I don't know if anybody has told you how to get access to OpenShift. So because you're interns, you should get access to an OpenShift cluster that's managed by either some internal team in PNT, or another cluster that's deployed on MOC, which would be operate first. But if you want to access, kind of deploy OpenShift on your laptop, probably the best option is code-ready containers, which is part of the Red Hat family. So developers.redhat.com, and then you could find more information about code-ready containers. What this will do is allow you to deploy OpenShift on a virtual machine on your laptop or desktop. Just know that because it's running on your laptop, there are resource limitations. So be aware of that. But we do have instructions for that on opendatahub.io on how you can configure code-ready containers with greater resources than default, but not enough not so many resources that your laptop will come to a grinding halt, which will happen. So once you've got a deployed OpenShift cluster, like I have here, every OpenShift cluster will have the operator hub. So on the left side, let me make this a little bit bigger. You'll have operators and then operator hub. So this is the kind of free marketplace where you can search for different operators that are available in operator hub. So what you want to be aware of first thing is you'll see things like community, community, marketplace. Community are free operators, meaning you can deploy them without needing any type of paid license or specific authorization or an agreement to sign or pay for. Anything that's marketplace is part of that Red Hat marketplace. That does require kind of a special access, but there are a huge amount of community operators. So majority of Operator Hub is community operators, and you can search for whatever you want on there. So there is Prometheus and Grafana are key ones, but we're going to demo Open Data Hub. So you can search for the Open Data Hub operator and you click on that. I already have it installed, but you'll be presented with this standard screen to give you information about the current release of Open Data Hub. So this is 1.0.10 is the current release. And then every update we provide kind of information on the current components that are available along with version numbers, because this is key. You want to know which features are available with these deployed components, and then information on how to deploy Kubeflow. So once you pull that up, this would say install, and this will take you to another screen that's a simple, I think you're one click away from installing the operator. Now, once that operator is installed, what does that mean? That does not mean that Open Data Hub is installed. It means that there is a operator pod running in the cluster that is waiting for you to tell it what Open Data Hub components to install. So whenever you want to do an install of Open Data Hub, all you have to do is create the namespace where you want to deploy it. Here I've created the Open Data Hub namespace. And while you're on this Operator Hub screen, you click on Open Data Hub Operator. And, oh, sorry, hold on. Installed operators, sorry. Once you've installed it, you click on Installed Operators. And then we're going to click on Create Instance. And it will default to this form view. I won't get into the specifics why this form view doesn't really work with Open Data Hub. But a high-level summary is our KFDef custom resource is very dynamic. So implementing a form view would allow us to make it easier to install some components, but we wouldn't be able to kind of provide kind of an easy web UI for all the components. So just click on YAML view. And if you're working with OpenShift or Kubernetes, if you're not familiar with YAML, you'll be an expert by the end of this internship. So with this KFDef format, we give you a default example deployment for it. But here you can kind of customize the things that are deployed. So if we wanted to deploy superset, we would leave it in. Otherwise, we would just delete it from the YAML and take it out. And that's kind of a simplified example of how these are deployed. And I won't go into specifics for the KFDef format, but we'll just stick to the example and hit create. And what you'll see is this KFDef format is created. An instance called Open Data Hub is available. And now if we view the available pods, we should see those come up shortly. Again, we've been plagued by cluster issues in our dev clusters, so hopefully this isn't the case. Let's see. Okay, let's start a roll. We're just waiting. But what will happen is the pods will roll out, And, this is here we go. Okay. So cluster's running a little slow, but now you see all the pods deploying. So if you think about if you were to deploy all of these applications, Jupyter Hub, there's the Odh Dashboard, Argo is deployed, Airflow. Each of these are a single application, and all of those applications have a lot of dependent OpenShift objects that they need to deploy. So in order to deploy any one of those applications, you need to be able to configure and deploy, I'd say a minimum of like 5 different Kubernetes objects. In some cases, they're 12 or 20. I think for Jupyter Hub, like we're deploying, deployments, deployment configs, image streams, making sure the relevant notebooks are updated and they have the necessary annotations and labels in order to be displayed. And we're also kind of configuring it so that it can access, a dedicated object set storage or object storage, along with configurations for different users to allow different type of notebook sizes, whether those notebooks can run on a GPU node, whether those notebooks are configured to access a Spark cluster, high memory workloads, you name it. There's a lot of consideration that goes into it. So in Open Data Hub, we make that easier for a user. So as a data scientist, you don't care about the OpenShift objects. You just want the path of least resistance to get running your Jupyter notebook running. And that's what Open Data Hub will do, and RHODS by extension. So once these applications are deployed, we've developed a dashboard that will allow you to view all of the relevant objects. So whenever you deploy an object, we set up a route. A route allows you to access the public, the web UI, the web dashboard, whatever you want to call it, of these applications on a public route, so external to the cluster. So with Odh Dashboard, you can log into this, and this dashboard will show you all of the components that are deployed in this deployment of Open Data Hub. And if any of these have a public or web dashboard that the user needs access to, it will have this launch icon available so that you can click on it and then be redirected to that application. Make that a little bigger. And with RHODS, we kind of extend this. So if there are tutorials and documentation, they will also have a tab on this launch or on this dashboard so that you have a one-stop shop for all of your deployments and information about their deployments. So you'll get the public URLs that you can access, the links to documentation, and links to any tutorials. And here we have Jupyter Hub. We're not going to make any real changes. You can select a different container size, whether it's small, medium, or large. And these can be configured by the user, or sorry, by the Open Data Hub admin. So if they want to offer large as a kind of large notebook, whether it's like, 16 CPU and like 500 gigabytes of memory. I think internal Data Hub, we have users that have 512 megabytes or gigabytes of memory for their pods because they're doing like a data intensive workload. We can configure that. And if as a user you wanted to add different environment variables to make available in your notebook, you can do that. If you had object storage set up, you could set the secrets, the access key and secret for that. And then you just hit start to spawn your notebook. And then what will happen is when the notebook spawns, you have a Jupyter notebook and you can do whatever you need. So just to recap, to get from an OpenShift cluster to a Jupyter notebook, within reason is probably about 4 clicks. And those clicks are kind of blind clicks. So you install the operator, which is about 2 clicks. Then you deploy Open Data Hub, which is 2 more clicks. And then you have the dashboard. Click on the dashboard route, which will direct you to Jupyter Hub, and then you could spawn your notebook. That is much easier than kind of trying to figure out which Kubernetes or OpenShift objects you need to deploy and how to configure your application. So that's kind of the beauty of Rhodes and Open Data Hub. We make it easier to deploy these applications. And all of these notebooks are set up so that they expose metrics. So you've automatically got a link to Prometheus and Grafana, and we had default dashboards available that will allow you to review that information. So, and there we go. So again, if you have your own OpenShift cluster that you have cluster admin access on, you can deploy Open Data Hub and get a good sense of kind of, the different components and get an idea of like what would be available in Rhodes. So with that, I will end the talk and open to any questions. I think the main question is, what is a community operator? I think I answered that, but to recap, community is just an operator that's freely available to install on any OpenShift or Kubernetes cluster. Anyone else? Cool. All right. Well, thank you. If you have any questions about Open Data Hub, feel free to reach out to us. We have an Open Data Hub chat room on Google Chat. There's also a Kubeflow chat room if you have questions specific to Kubeflow. The Open Data Hub chat room is great because it's not only Open Data Hub maintainers and AI COE and AI services, it's experts that are working with customers on their different AI workflows. So even a purely kind of data science question about running on OpenShift can be answered by anybody in there. So that's it.
Awesome. Thank you so much, Landon, and also really appreciate the live demo as well. So yeah, if anybody has any questions, feel free to reach out to Landon as well as other folks on the Data Hub team. And we also do have some more sessions lined up, which will again touch base upon the things that Landon just walked us through. Mainly, we have one workshop by Sophie and Audrey who will give us a little more detail about how exactly do we use these applications from an OpenShift environment for data science purposes. And yeah, with that, we can end a little sooner and also give you some time for a few minutes break before we move on to Sophie and Audrey's talk. Thank you, everyone, and thanks, Langdon, again.